Okay, excellent. Got it. Screen still shared and everything okay?
Yeah, everything looking good.
Fabulous. Okay, hello everyone. I am Scott Mason. I am one of the directors of Mesh Energy, and I'm delivering a presentation for you today for this Wednesday webinar talk about some of the fantastic work that RIBA and LETI have been doing, but primarily around their alignment of different targets, which we'll sort of look into as the presentation flows through. But the developments sort of over the last year or so have been quite major, and the definitions of embodied carbon have come on somewhat as well. So it is quite interesting. Not masses has changed in the last few months, but it's just good to sort of have that, have that recap and make sure that we are staying current. So without further ado, with regards to housekeeping, obviously this is a Teams platform, so please leave your microphones on mute for the presentation if you can. Any questions you've got, please put them into the chat box, because what we'll do, I'm going to speak at you for about half an hour probably for the core of the presentation. If you ask questions as you go, what's going to happen at the end of the presentation is Kat is going to ask me or relay those questions on, so I'll be able to field them at the time. And then of course as well, I'm always contactable either through MESHWORK, or if you want to just get in contact direct, I can put my contact details up at the end of the seminar anyway. This webinar is going to be recorded as well, so it's going to end up on Mesh Energy's YouTube site. It's definitely worth checking out our YouTube site. There's loads of previous content, and I think one thing as well is the presenters often change. So I deliver a presentation, I think the content's, it's delivered by me, so it's sort of in my form. If you were to hear that from maybe someone in the operations team, or maybe one of our other directors, or Doug, the main man himself, then obviously it would come across differently, and you'll get different sort of key takeaways based on who's delivering. So if you are interested in the topic, don't watch it once, I'd say watch it twice, because you don't really get the same reel of content. And now I'm just going to pass over to Kat quickly to introduce MESHWORK and what it's all about.
Right, so all you guys will probably know what MESHWORK is about because you're on the site and coming to our CPD. But for those of you who don't, or is new, or anyone who's going to be watching on our YouTube channel, I thought I'll quickly run through what MESHWORK is. So MESHWORK is a platform for people who are interested in sustainable design. We're really here to help facilitate education and networking, and we're doing that through CPDs, getting some great Q&A sessions at the end, our new Lunch and Learn, and our great new thing, which is our networking sessions, which are starting this month. So one which will probably be relevant for you guys as you're wanting to learn about embodied carbon is we're doing a networking session on embodied carbon on the 20th. So it's going to be an hour. We've got a guest lecturer, Sophia, coming along, talking about her experience of building in embodied carbon practices into her architecture firm. And then we're going to be splitting out into breakup rooms and chatting through a few challenges facing implementing embodied carbon at the moment. But yeah, if you're interested in that, give me a message either through MESHWORK. I'll put my email in here later, but it's going to be really good. I put it up on Monday, and now we've only got 9 spaces available, so it's gone very quickly. But yeah, the other thing is, if you know other people who are interested in MESHWORK or wanting to learn more about sustainable design, please do tell them about it. We've hit 1,000 members, which is amazing. I didn't think we'd ever make it to this day, so that's so cool. But with the more people we're gaining and the more things we're able to do and the more education we're able to create. But yeah, that's all I was going to say about MESHWORK. But yeah, if you're ever interested to learn more or find out a bit more, give me a message.
Thank you very much, Kat. There was actually 2 slides there, so I probably should have clicked through, sorry.
Right.
Okay, lovely. All right, thank you very much for that. And then without further ado, what I will do is I will commence the presentation. So very quickly, just for the purpose of the presentation, so we can understand the standpoint sort of the information is going to be delivered is coming from. So we're Mesh Energy. I'm sure a lot of you have heard of us, certainly being on the MESHWORK platform. But what we are is a independent, holistic renewable energy consultancy. So we can be involved in many stages of a project and the project life cycle, right from, typically that RIBA stage 2, sometimes 1 as well, right through to post-occupancy evaluation. So it's a real turnkey look, very supportive role. And the industry is evolving and moving so quickly at the moment, and it really is, you know, sort of the time for the building services engineer to become a bit of a rock star, really, and that it's so mainstream and current. So for us and what we do, we're in a very privileged position, being able to work on this sort of dynamic range of projects, but also through the various stages. So it just gives us that real turnkey look at a project and the impact that can have later on down the line. So what we're going to do today, I'm going to give quite a quick, well, really it is going to be quite a quick condensed rundown of the topic. So the session's probably going to last realistically about 45 minutes in total, with questions at the end. So there will still be a little bit of a chance to, you know, go and have a lunch. You're not going to sacrifice your whole lunch break for being here. And what we're going to look at is embodied carbon as a whole, and a few of the notable differences between LETI, which is the London Energy Transformation Initiative, and RIBA, and the new rating systems which have been drawn up. And we're going to talk about the synergies as well throughout the other areas of the industry. We're going to look a little bit at the RIBA 2030 climate challenge as well, look at some of the updates, and do a final recap, which is effectively our core takeaways from the session. So there's been a pretty substantial bit of work done over the last couple of years with some really big players. You know, RIBA, the Greater London Authority, UK Green Building Council, ISTRAT. And, you know, last week, actually, I was fortunate enough to be at the that housing development just outside Bicester in Oxfordshire, that super green futuristic development where there was people from LETI and the UK GBC giving a presentation on sort of their involvement in that process. And it was really eye-opening, interesting stuff. But what I would say is, off the back of that presentation I was at last week, there are some additional things which are worth checking out on the LETI website, which are initiatives they're currently working on or have released very recently that might not feature in this presentation. But links to the LETI stuff is going to be on there later on anyway, but just be conscious of that. You know, there is stuff beyond the items that we're discussing today in these headliners. So early on, you know, when embodied carbon started sort of becoming a thing, for want of a better term, you know, the definitions were actually quite sporadic. So this sort of crack team got together and met to put some meat and definition behind the term and what it means. And the UK Green Building Council has looked at, even a year ago, it was thousands, so many thousands of case studies to make sure that the targets are better aligned in the future. So this squad here is effectively key contributors to the work that we're going to be discussing today. And as I understand it, LETI are kind of the glue that binds this together. So again, make sure you check out their website because they're very good at displaying information in a clear, concise, bite-sized manner that makes it really palatable. And you know, I've got a reasonable attention span, but I do sometimes struggle with long technical documents. So actually, these headliners are fantastic. So there were quite a few pieces published, and these actually came out probably about a year ago initially. So this one here for embodied carbon is based on aligning and defining embodied carbon, so what it is. And then what followed were basically a few documents which they've done incredibly well. You know, I've said they're very palatable, very easy to read, but it really does help to create that synergy between different practices and what the definition of carbon actually is. So this second document for embodied carbon target alignment, you know, again, I think they're actually defined on the website as one pages. And what we're effectively going to do today is draw from these documents which have been released, not necessarily just the one pages, also the supporting literature behind them, but to talk about sort of some of what in effect, I suppose, are my key takeaways from it. So this isn't an opportunity to, you know, not read these documents, because there'll probably be bits in there that mean more to you. There might be bits in there, or you might agree these are the key takeaways, I don't know. But for me, these are sort of the key bites which I think should gauge interest and allow us to draw into these individual items. So fundamentally, what these documents are about is sort of addressing why alignment's needed. So the IPCC, which is the Intergovernmental Panel on Climate Change, you know, their recommendations have to be met. So without a doubt, something needs to be done to massively reduce carbon emissions globally. And, you know, statistically, we can't quantify and measure that without creating some kind of consistent measurement. And, you know, without consistent measurement, what happens is you end up with, and without alignment, what happens is you end up with a lot of interpretation or different length measuring sticks. And then what happens with the different measurement sticks or different interpretations sometimes comes, you know, either maybe slightly glossier outcomes than what might have been measured otherwise, or possible abuse of the system. And because net zero is becoming such an incredibly trendy buzzword and getting so, you know, bounded about everywhere, you know, it's probably one of the most prominent terms I hear at the moment. Everyone says something relating to net zero. It's just important to understand really, you know, like what it means rather than having these individual definitions or perceptions. So I suppose the last thing would be as well, the measurements need to be meaningful. If they're not meaningful, people won't get behind it. And if people don't get behind it and understand the purpose, or certainly their purpose in the role of creating or getting to those future targets, you don't pull in the same direction. If you don't pull in the same direction, you don't create as much power as you potentially could have. So alignment really, as a concept, is an incredibly positive one. So this first diagram we're going to look at, although it does demonstrate some kind of alignment, also demonstrates some differences. So what I'm going to display now effectively is the main difference between the LETI and the RIBA definition of embodied carbon. So I apologise if you can hear ducks in the background. That's a very bizarre noise I've got coming from outside, but anyway, that's fine. Okay, so upfront carbon. So upfront carbon, and I actually think that's quite a nice explanatory term. And, you know, it sort of defines nicely what it is. It's your raw material supply, transport, manufacturing, construction, assembly on site. So effectively the upfront carbon elements, not including any kind of sequestered carbon though. And this is effectively how LETI define their targets. So when we look at some of the benchmarking figures and values later on in the presentation, you'll notice that the LETI values are often lower. And the LETI values are often lower than the RIBA values. And that's because RIBA define it somewhat differently in that they will consider the upfront carbon, but they use this more generalized embodied carbon term that takes into account further down the line stages, such as the end of life stage, in use stage, and sequestered carbon throughout, whereas LETI is more just that upfront carbon element. So by the time you're taking into account the other stages, obviously the embodied carbon goes up, the sequestered carbon brings it back down. This is why there is differences in the portrayed values, but ultimately the rating system, which generally is on A to G, which we'll look at shortly as well, they don't end up a million miles away. And then one of the other key diagrams, which I sort of drew from, was the hierarchy of embodied carbon reduction. Now, this is a really nice little cycle, actually, and really easy and clear to follow. And it just looks at, like, during the design phase, the concept of reuse, repurposing, reducing weight, taking out load, reducing steel works, building smaller, all of these things that seem so basic. It just allows you to make, you know, considered decisions at various points quite effectively without forgetting anything as well, because there is so much going on when it comes to designing a building. And it's just quite a nice, simple flow that's certainly worth mentioning, because it just gives you those quick prompts and allows you to very quickly identify, in effect, I suppose, quick wins for where you could reduce embodied carbon through the embodied carbon reduction process. Okay, now on to the letter banding. So this is another very interesting diagram. I'll leave this one up a little bit longer actually, so we can digest it, so we're not rushing through. But basically, from a letter bandings point of view, this is going to look very familiar. What sort of been settled on, I suppose, for want of a better term, is this A++ through to G style of rating. Now, this is going to look very similar. You know, it looks like EPCs, or it might look like you know, when you buy a new washing machine, you have your data labeling for that, which gives you your A to G rating, or even, you know, the Green Guided specification, the database run by the BRE for embodied carbon in materials. That's still like an A to C rating, but just for embodied carbon in material rather than embodied carbon in a build. So we're drawing those synergies across the different areas of what is in effect building, or the things that go into buildings, and it's become quite a easy mechanism for display because it's actually become quite prominent and current in our way of working and mindsets, I suppose. And what they refer to is, well, actually, before I say shifting the peak, sorry, what you've got here is our band of building qualities proportionalized for RIBA, right? And the current average building design is actually, in that metric, roughly around this E rating. The LETI good building design is around this, well, no, sorry, the RIBA good building design is around the C rating. The LETI bandings is this peak here. So it's about shifting this peak over to the left, so the dashed line. So a C, which is currently considered good, effectively an A, you know, what is currently described as exceptional is going to be the 2030 design target. So you can see about shifting this peak. It's all about sort of moving what our perception of acceptable is. And again, it's a letter banding system. It just makes it easy to look at and define and see what it is exactly we're looking at. But I think, you know, for an excellent to be around the A mark, an exceptional build is going to be the A++ standard. You know, things are going to change in the distant future, I'm sure. But I'm saying distant, you know, this is just around the corner. 2030, once upon a time, felt like a long time away. 2025, when you look at RIBA 2025 figures, that once seemed like a very long time away. And now we'll be working on and planning projects, which, to be honest, won't have completion until those dates, no matter what standard we're working to. So, you know, it's all going to come around very quickly. And this is just sort of building on that. So I think what's important to state is, and it is slightly more complex, I suppose, than that A to G lettering system we looked at, but this is effectively all voluntary. So there isn't anything really in law setting your aspiration for an A, B, or a C. The LETI and RIBA targets do land slightly differently as well. So your RIBA 2030 target would be the equivalent of a B. The LETI aspiration was somewhat, well, slightly higher for that A for the design target. It's just not displayed on there. And the whole life building factors, though, and the reason that these fall short, I think, is because achieving an A for upfront carbon versus the RIBA built 2030 target, which is a B. Now, remember, they take into account some different things in that you've got effectively sequestered carbon in the RIBA values, which is why the RIBA numbers are bigger as a result, which actually brings down their rating. And you've also got, you know, the other additional stages that go into a project. I think something like that A1 to A5, so the LETI bandings, that upfront carbon value is roughly 60% of the project carbon value, excluding sequestered carbon overall. Okay, so what that sort of means then. So we have two coloured matrices here. At the top, we've got the LETI definitions. At the bottom, we've got the RIBA definition. The LETI definition, remember, excludes sequestration. Embodied carbon includes it, but also remember it includes those additional stages. So when you look at what it is we're actually targeting for the different letter bandings, well, I suppose what's also very important to note as well, just while it's in my head, it's broken down into these 4 different areas. So it's office, residential, education, and retail. So it's quite well accepted that obviously these different building types have different forms, different massings, different expectations and appearance and whatnot. And the impact is they end up with different targets. And the different targets you can see for, I don't know, for an A++, for example, for the LETI definitions, there's not much change. When you look at the LETI definitions just at a glance, it's only when you sort of get down to C that you see between the individual building types, there's actually that significant a change, I suppose. When you get to this top end, there's just sort of like small jumps. Then when you look at the RIBA targets, are that little bit higher. So the A++, we're saying we're looking for a 150. Remember these values as well stated down here as in kilograms of CO2 equivalent per meter squared, but that's for your gross internal area. It's very important to remember it's gross internal area because we're talking about the building, not the site, when we talk about this. And yeah, the RIBA values are always higher because they include the additional stages, but then they also include sequestration. So 60% stayed there. So that 100 plus 60% minus sequestration takes us back down to something lower than 150 for an equivalent value in terms of kilograms of CO2 equivalent per millimeter squared. And this graphic is basically just another way of looking at it. I think it's quite a nice snapshot because it actually, it allows you to weight the, what would the term? Stringencies, target values between the different building types. So you can see which are going to be harder to achieve effectively at a glance, which have greater expectations, I suppose, at a glance, again, because of things like your form and whatnot, we just spoke about earlier. And yeah, it's just an excellent way to, just another good way to display it. So another thing that's been picked up is embodied carbon reporting. So this is going to be a big change for us. And effectively what we all have is a professional responsibility to report how our projects go. And this can be used for future analysis. So we can help refine future targets. So the more we share and the more we're informed and the more we, give information, the more other people can benefit from that, and we can end up collaborating in a way that actually benefits the industry as a whole, because it means we end up with these more realistic expectations or more realistic target values. And I suppose actually, that alludes back to what Kat was saying earlier during the introduction. It's what MESHWORK's all about. It's about connecting and bringing together like-minded professionals within our industry and having that collaborative forum. So it's very much, in keeping with what we should be doing. And when we report on how a project's gone, you need to have a really good idea of about 95% of the project cost when it comes to materials. Now that's 95%, that's quite a substantial figure. And this needs to be included. So there's a fair amount of detail that goes in there. So when we include things like, I don't know, the substructure, finishes, there's a lot of variation to take into account. But remember, it is within the building's footprint, not site-wide. So it's the gross internal area in square meters. Sequestered carbon, important to note, it is reported separately. So for timber product, for example, I think different people have different thoughts on this. I think for me, it kind of makes sense. It certainly is a bit fair. And this is because, that product during its cycle of application, which effectively is it growing in the first place, but when it has grown, it has absorbed CO2 during that frame. So yeah, I think sequestered carbon, I don't know, that might be one for the network and see some general feedback, maybe by the way of a poll or something. But anyway, so to help with projects that have embodied carbon as a part of them, someone has put together this very useful embodied carbon reporting document, which is effectively an Excel document. So it's an XLS, which you can download from LETI. And what you do is, depending on what we're looking at, whether it's LETI, RIBA, whatever. On the right-hand side, we can populate all of these different elements. So things like facilitating work, substructure, superstructure, finishes, F&E, building services, and it will automatically, based on your input, give you a value on the left-hand side and benchmark you on an A+ to G rating. So it's a really nice tool, good visual indicator, certainly very helpful at those early stages of a project, and it will show you the difference between your upfront carbon and embodied carbon, depending on how much data we have to populate. But like we said earlier, you know, you've got that LETI definition, the A1 to 5, then you've got the embodied carbon RIBA definition, which is those additional steps in effect, which will be A1 to 5, B1 to 5, C1 to 4, and then sequestered carbon listed separate. Okay, so RIBA 2030 climate challenge. So some things have changed, lots of things haven't. Now, when we're looking at RIBA 2030, you know, it's important to remember we've effectively got these 4 quadrants that are always displayed. We've got our, you know, our embodied carbon value, we've got our operational carbon, we've got our water use, and we've got health and well-being. But what they've done within the document is they've now made some suggestions, and basically today we should be, what's being said is today we should be designing to RIBA 2025 as a minimum. And that, to be fair, is a very reasonable comment, given that it is just around the corner. They've differentiated between different building types, which sort of wasn't done previously. You're now encouraged as well to submit data, obviously for that sort of future checking and making sure that values are listed and, you know, sort of refined appropriately in the future. And at the tail end of the document as well, there is a climate challenge checklist. So that's worth checking out as well, because it's just nice, informative, additional bit of information that can be gained. This graphic has been updated. So we've got 2021, 2025, 2030. And effectively what we've got is our trajectory that shows us working towards that 2020 value. Now it does say aim here now for 2030, even though the recommendation is at 2025 figure, but that's fine if you can do. What we often find is when we're working with people and we're working to different standards or different ambitions are being set, depending on what information is available and depending on what stage you are in the project and how the project flows and how viable different elements might be, it could be that from those 4 quadrants, certain things are achievable, certain things aren't, and you end up landing somewhere between the 2025 and 2030 figures. So it might be that you can get your embodied carbon down far enough and the operational carbon, but the client is very insistent on high flow volume taps, for example, which might tip that value over your water consumption to allow you to comply with the water future figures. But you know, or any number of things, but often it is very achievable to be between those 2 benchmark points. Okay, so there's 3 different sheets here. The first one we're going to look at is domestic, then we're going to look at schools, then we're going to look at offices. So just this one just specifically is domestic. So I think the interesting thing to note on this one is when you look at this versus the original revision, the embodied carbon value for 2030 used to be a value of less than 300 kilograms of CO2 per meter squared. No, I mean, raising the bar is usually a good thing. So what's the way to word this? I suppose it's increased from 300 to 625 as the 2030 target. So it's quite a significant increase that, you know, it used to be 300, we times it by 2.1 effectively, and our new target value is quite a bit higher and therefore as a result obviously more achievable. I don't know why that's happened. Maybe someone could drop the answer to that in the chat. If you know, that'd be fantastic. But then equally as well, you know, the 2025 target was also quite out. The 2025 target was, you know, the ambition was less than 800. Well, it is now less than 800. It was less than 650. So that's also gone up as well. So I'm not sure what's caused that or why the figures have swung so much, but they've both increased somewhat. Yeah, and it would be good to have a better understanding of that, of the reason that might have increased from an embodied carbon point of view. Potable water use stayed pretty consistent. You know, that's 75 litres per day. To be honest, from a RIBA 2030, from an achievability figure, that is often quite doable. Remove a bathtub and introduce some rainwater harvesting, and that's often quite within scope. I mean, that was quite a sweeping statement, I accept that, but you know, these figures should be, you know, from a water continuity point of view, using City Guide G, that is doable numbers. For schools, very little, I suppose, by way of change. And offices, I suppose, a little bit slackened, but not a massive change. You know, we're talking about tens, not hundreds, like we were for domestic. So yeah, nothing major to report there, really. So checklist highlights at the back of the document. There are a couple of changes to the checklist. So we should be looking at post-completion info 1 year on. So post-occupancy evaluation should be an encouraged thing. From 2025, we should, of course, only be using low carbon heating. We should design using realistic building performance predictions to minimize performance gaps. So what we mean behind performance gap is obviously when you start out early stages in a project, you're at that like stage 2 doing your projected values. They often look, well, you end up with a value which is often lower than the realistic end up figure. And that kind of comes down to accuracy and detail in upfront modeling. So more focus on upfront modeling, making sure those projected values are more realistic with what actually happens post-occupancy. And what should also be encouraged as well is, you know, it's not our responsibility to get the person in the property and then step away. We should be assisting with that post-occupancy evaluation if possible and guiding. We should prioritise retention, reuse and repurposing of buildings where possible. So rather than you know, knocking down a building new. And the bill of quantities certainly needs to be better understood. And use embodied carbon LETI hierarchy design guidance where possible, which was the extract we looked at on probably page 6 or 7 of the presentation. We're talking about that flow of snippets of information we can use to help reduce the embodied carbon in the building for the stage. So key documents. So the LETI website, I appreciate I can click this. You may not be able to click this because you are looking at a shared screen, but the information is there. I can drop the links into the chat. But if you open up the LETI carbon alignment page, it gives us lots of great information. But then if we click on publications, that is where you can find these one-liners we've just been discussing. They should look very familiar. We've just looked at them briefly, and you can see sort of when they were published and the rest of the core information behind them. What they've also done recently, which I think is pretty awesome, which we've not spoken about in this presentation, but kudos to them, is a bit of a emphasis on climate emergency retrofit guide, which is great. So that came out in October last year. Check that out. It's obviously a really nice, useful resource. And the RIBA 2030 climate challenge document is all, well, if you click that link, which will be in the chat, it'll automatically download the PDF for you. That's what's also worth checking out. The link also is here, but there is a embodied carbon calculator which is free, which encompasses a lot of these changes and evolutions, well, all of them really. So Mesh Energy's embodied carbon calculator, that shouldn't say V2, that's just what it says on the download link for some reason. It is of course V5 now. So jump on that, and that is a very user-friendly way, certainly at those early stages of a project, to tap information in and get a projection of where it is you might sit. Now, I appreciate very much that was quite whistle-stop tour. We were only looking at sort of small, quick areas during this presentation for, I suppose, highlights for major changes. But I suppose now would be the opportunity, if we have any, Kat. I can see that there is a red circle above chat. I just can't see the number. If we have any questions that might be worth delving into.
We don't have any questions just yet. What I was going to quickly add to the Mesh Energy Embodied Carbon Calculator is our version 6 is going to be released this month. Doug is going to do a very, very quick CPD on it, which is going to be like a quick tour of how it's updated. I think he's done some updates, which means it can be used a bit more globally than it was previously. And we've also got our embodied carbon group. So if you head down to resources in the navigation section, you'll see the embodied carbon group. If you're using it and you've got some questions, pop them in there. Doug and Jen are always looking at it and helping you guys out if you've got any questions about using embodied carbon. All right, so we've got a question coming through. We heard that solar panels are not great for embodied energy, so don't help towards upcoming targets. Can you please clarify this for us?
Okay, so embodied carbon, well, embodied energy. Yeah, I mean, obviously there is an additional intervention going into the building. It does increase embodied carbon. There obviously are processes associated with, you know, when you think about what goes into embodied carbon, including transportation and whatnot, it's not often you would find a panel supplier who's manufactured, assembled and found the, you know, items that go into it in the UK. So there is a value associated with that. Now, what I would say is when you, although maybe not great for the embodied value, the operational figure, because you can end up with this bit of a trade-off. If you've got a building which is using quite, you know, futuristic style of technology to, you know, heat it, and the small element of passive ventilation is picked up by MVHR or whatever it may be, if there is a lot of electric potentially being used on site, and that PV allows you to offset a lot of carbon by being on site and used on site and projected appropriately, it can have a very positive impact, but mainly on the operational carbon quadrant. And because all four are being, you know, sort of taken into account, you always end up with this like constant balance and trade-off. And yeah, it's just so job by job that I can't say it's they're necessarily a bad thing, but it might be the tipping point that takes you over on another quadrant. So
yeah, no, that's definitely true. It is a balancing act with all of this. Unfortunately, everything you add into your home is going to have an embodied carbon value attached to it. But if it's going to provide something useful like energy from solar, sometimes it is really worth it, obviously. Does anyone else have any more questions? If not, we'll wrap it up. I will stick it up on YouTube and on the MESHWORK site. And if you guys think of any questions later, feel free to just attach them to the article I'll pop up later today with the video attached to it. We'll always look over them.
brilliant. Okay.
Right. Cool. I think that's everything. Thank you so much. That was really interesting, Scott. I've definitely learned a lot more than I did beforehand.
Yeah, thank you. I hope it was clear and concise enough. But like I say, if anyone's got any additional questions or needs clarification, just reach out to me. Yeah, here to help. Get us on MESHWORK.
Brilliant. Brilliant. All right. I'll end it here. Bye.